today is that we'll go through majority of demos and some theoretical as well. I was keen to finish this databases today and some, VPC creation, EC2, NAT gateways, what happens, what do you mean by setting up a VPC, what the impact of setting up a VPC is, and then look at all the on the database side as well, right, to see what actually database does. And there are some services which is more theoretical as well, and then to explain those theoretical concepts as well along the way so that you understand the architecture, what exactly that service does, even though we can't set it up live because of the infrastructure relation problems, and some of the services take a lot longer to even start up. So like directory service take 4 hours just to kick off, right? So we'll kick it off, like we'll go with the first service. So one of the service I want to teach is SQS. I'll open up the dashboard. Now, SQS is is a service. I think on the first class, no, second class or first class, I explained a concept called as SNS and SQS. I'll go through it again. I'll just move participants in case Farkuni joins and she needs us, right? So in the first class, when we set up that billing alert, we had something called as SNS and SQS topic and a broadcast. I remember I was explaining the topic and the broadcast, right? So which I was saying that you could have something like uh, a message broker sitting between, right? And there's a participant that can this people can send the message, one participant, and then you can get a lot of messages out of it, right? There could be loads of participants. So that was what SNS was doing, simple notification service, right? Right. And you broadcast message and then you can send it. So AWS took the same concept in a similar way, right? So you can say, okay, I want to send emails out, right? So emails could be like loads of subscribers could be there to that emails, right? It could be like I'm broadcasting a message out to them, right? So what they've done is they've written as SNS, which is fine. The SNS is fine, but then comes the problem is that it is not good for real life architecture. Now, real life architecture, the problem that happens in our architecture is that, let's say that I've got an app, right? Now, if I bring in this, I can say that, okay, there are a lot of broadcasters, we can say, okay, you can send a message to it. Maybe you get an email and then you process it or whatever, right? But actually, that's not how the apps work in the real life environment. Usually you have something called as a queue. I'm going to explain the architecture, how basically it happens. And you push the messages into this queue. Now, each message, right, can have different formats. You can have like JSON format. You can even put like whole XML in there, or you can put like a CSV or a spreadsheet. You can even, encrypt it. You can just load the data in bytes. So there's loads and loads of providers, right? You can name it like ActiveMQ is one of them, getting popular nowadays with Java World and .NET and other things. You have MSMQ from Microsoft, right? And then you have WebSphere MQ. Sorry, right? You have loads and loads of them, right? And all they do is you're sending a message, they store it somewhere. So they may have their own storage. Maybe it's maybe a file drive or a database or somewhere they store the message. And in this side, right, there may be loads an app, you send a message out, but this message only goes to one app. There could be loads and loads of consumer, but you always get one app uses the message. It's not like a broadcast where you're saying, oh, just send it and don't know how many people are going to listen. No, it's one app. And 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 this has lots and lots of examples are used in production world for it. The reason is that, let's say that I've got a CSV file. I've got 1 million records in that, right? And what I want to do, I want to process all this 1 million records. Now, one way is that I can take CSV, put a for loop, and go up to 1 million, right? And then process each of them, each record, right? Or I break it into chunks, right? Or I can say like this. I can say, all right, I want 1 million. Let's say that Maybe I create a 1 million message in the queue. Now each CSV record now become one row, one record, one sort of a message, right? Which may be like a string or something, whatever it is, right? And I push them all 1 million record into this queue. And I can write loads and loads of apps now that will pick up one message and keep on processing it. So one first line maybe will go there, second line this guy is processing, third line this process. So I could like scale up and down. I could have hundreds computer here, or I could only have two. If it is less, I could even leave with one. Or if this all application die, I still got the messages there. And when this application start, it will start getting the message again, right? And this is the concept you do in SQS. So basically in SQS, you push the message in SQS, and there may be some other app you write your programming app, right? And then you process the message. And in exam, you will always see this question will come to say, I've got loads and loads of messages coming in. What can I do? And the best answer you do is spot instance. We discuss about spot instance. Now, spot instance give you 90% anyway. So the idea is that let's say that I push 1 million message into this queue. I can do spot instances. Let's say I put 10 spot instances, right? And then I can get the messages, and this messages can keep on processing in 10 spot instances. Let's say that spot instances get taken over by somebody else, right? Maybe that, we put a max amount and no, AWS said, no, you can't. And then what will happen? The messages are still there. And then you can come back and maybe try again, maybe 2 hours later or 3 hours later, right? You can still get to it. So in that way, there's an advantage because you can still process the message, but then you still got a problem. Let's say that at 500K message is still pending, spot instances can't come for a day. And what usually then to get around this problem as well, where you're going to have only spot instances, what this company does is basically is go with a mixture of things. Number one, they buy something called as reserved instances, which we haven't looked, but we're going to look now. Number two, they mix with something called as on demand, which we have looked to start the EC2. And third one is on spot. So they bring a mixture of these three things in this architecture. So what they will do, they will say, all right, I've got a queue, put two reserved instances, right? Put two reserved instances, right? And put maybe four spot instances. And if my spot instances goes completely down because of AWS not taken out, I can always start up on demand, right? Like EC2 and run my app on EC2. Maybe I put four on demand instances, right? So I can have a mixture of apps running and these things, right? And that helps the architecture. It reduces the cost down. The things is still running in parallel. You don't have to worry about it. It just keeps going, right? So your app is still continues going to run regardless of what is happening on the infra level, because you still got reserved instances that's always going to run. You still have on demand that you can kick off, and on spot will just reduce your cost down, right, in a heaviest possible way. So you can even have 100 spot instances just doing the work for you in 1 million record. And the idea usually what actually happens is that you watch this queue. As more messages come, you may start more spot instances. If less messages die, spot instances die. And that is done through application scaling group. So we're going to look at this maybe today or by tomorrow. We'll get there in application scaling group. So that automatically takes care of it to up and down the instances, right? Now, if we look at the SQS itself, before that, I just wanted to close this reserved instances because we touched on it. Now, reserved instances actually is something that you buy upfront for 1 year or 3 years. So AWS is saying, okay, why don't you come and buy from me upfront, right? You pay me for 1 year or 3 years, and the instance is yours forever, whether you use it or not. You just give me the money. You're running 24/7, or you're not running at all, or you're just thinking that I'll keep it for some spare capacity. That is not our problem. Our problem is that we want to start this reserved instances whenever we need to without any worry. We're going to pay it upfront. And the idea is that you go and purchase reserved instances. If you see, you can decide what you want to do, which one you want to buy, for what terminology you want to buy. You only have 12 and 36 months, right? So when you buy for 3 years, they'll give you reduced cost. So you can go and pay them, the money. They'll give you like discount for 3 years because they've already given you the machine for 3 years. They'll give you heavy discount, right? And then you can tell how I want to play. If you pay all upfront, means you've already done for all 3 years. You're not going to get any bill for next 3 years for this EC2 instance. You've already paid upfront. They'll give you heavy discount. Don't give an upfront, they'll reduce, discount will reduce. If you pay partial upfront, you're saying I'll pay maybe like 300 pounds now and then, or 300 lakhs or whatever, and then I'll pay rest of them later on, right? And what do you want to do? The dedicated we saw, like, is it full server you want or your own one? So I say like default dedicated is used very less until you bring your own servers in place, and what you want to install, etc. And once you have done it, then you search it, and then basically you can say, okay, what cost is saying this is your upfront cost. If you pay this, this is the charge I'm doing. But if I go and buy somewhere from like on demand, I may be paying 10 pence for it or something like that, right? So this is what reserved instances give it. Now, what actually happens is that this is the whole time I'm going to run 24/7. Now, what AWS said is that sometime you don't need 24/7. You may need it just for smaller purposes. And then they brought it the scheduled instances, right? So they're saying that reserved means like it's mine 24/7 for 36 months, 12 or 36 months. This one schedule is saying, okay, why don't you just give me for a few hours, right? I only want to run my app for 3 hours or 4 hours, right? And I would like to run this app, and you give me the cost, and I will purchase it. So I'll purchase it from this time period to this time period. I'll purchase every day. Let's say my app runs at every day at 9 o'clock to 10 o'clock. I'm doing some report 9 to 10. So I may buy an app for just a reserved instance for 9 to 10 for 1 hour. And once my 1 hour is done, my app is going to shut down, and I'm only going to pay that bill for one. But I'm guaranteed my instance is there. It's not like spot instance where AWS can take it back. Between 9 to 10, my app is there. I've reserved it. It's like a movie theater. You reserve your seat, it's there for you. If you do it for whole movie, maybe it's like the full reserved instance for full movie means it's your, whether you turn up or your flight is late or whatever is late, your movie is gone. But if you do a schedule instances, you may have a duration where you're going to say, I only want to say up to interval, and then I'm off, right? And then if you run after interval, you're going to pay on demand price because your reserved is finished. You're going to click on the on demand price, right? So that's the two things that happen. But the SQS one that which we're discussing, right? If I go back to a service called a simple queue service, which is SQS. Now the SQS one is fairly straightforward. There's two things to understand there. Now, if I go back and if I just delete this, right? Now, there's two things. Now, when I push the message in the queue, how the SQS work, I think that you will find a question exam on this. So this is my queue. Let's say. Now, I will have loads and loads of spot instances maybe running here. So I've got this one spot instance, 2, 3. I'm keep going, right? I push the message here. How this works is the messages are stored here somewhere, maybe in there, whatever AWS want to store. Let's say that is storing in a file system or wherever, right? Or in memory, whatever it wants to do. When the first message picks up this message one, so let's say that message one has come in. I picked up this message one, gone back. What it does the message is not deleted or anything. It hides the message. And there is a timeout called as visibility timeout. Means for 30 seconds, SQS won't see the message. Now let's say that this message for 30 seconds, let's say that this message was very, very slow and it took 40 seconds to finish. Maybe it was like calling a database and network was jammed up. You retried, 40 seconds are up. What actually happened is after 30 seconds, AWS, because this message is hidden, right? And let's say that it was hidden, number 2 may go to somewhere else, right? And this guy is processing number 2. Because 30 second onward, and if this guy, number 1, don't come and delete the message from the queue, this message comes back into the queue. So what actually happens is the message is sent back into the queue. An exam, there will be a question usually they ask is, my question, my message is duplicated, right? What can I do? The reason is your message is duplicated is because the visibility time it was so less. So let's say that our visibility time is 2 seconds. That means in 2 seconds, if this guy, whoever picks it up, doesn't delete the message is going to come back. And if the message come back, it's not like he's going to pick up number one again. This time, the number one may go to three, and he's going to start processing again. And this time, it may be successful, or it could have been successful here, but it was just a delay of more than 30 seconds. And visibility timeout helps in that. Now, as you saw that I can pick up the message and delete it. If I don't delete it, it's going to come back. Now, to solve this problem, they brought a new queue called as first in, first out. That means that if my message one is gone out, this has to finish before my next message number two can be picked up. Even though I have hundreds of machines, it is in order. This will go out. When this goes down, maybe second will start on this one, right? And that means the speed of first in, first out is very slow. I think it's only 300 messages or so, right? This one is very fast because it doesn't care. It just, if you had 1 million spot instances and you had 1 million hints messages here, all 1 million are going to go. Maybe 100 will fail back and then 100 will come back and then put back and retry again. But that's how the SQS work, right? So it's something to remember is the visibility timeout. And what actually happens is that we'll see the message and then I think I'll explain the next concept. So you can decide what you want to do. First in, first out is slow. Standard means don't worry about it. At least means that there is no guarantee. Means it's like I've sent it. If the message visibility timeout come back in, I'm going to come back up. And message can be reappearing on the queue. So duplicated is duplicated, and this is how you set out visibility set timeout, right? So if I say my queue is called as demo test queue, right? You can say, okay, what do you want? Messages still be stored there. If I'm not picking up the message, still leave it there. If there's a delay, etc., you can configure it. But visibility timeout is what determining when that message is hidden from the queue when somebody picks it up. And if 30 seconds later the message is not processed, it's going to come back onto the queue, right? That's how it happens. And then once you set up, and there's a maximum size of the object, you can say it's only 256 kilobyte messages. um, and and then it's like who can access the message. Like you can set up your user, like separate users, etc. It's just setting up a policy to say, oh, which accounts can use my queue, etc. I'm just saying, okay, I'm the one. I'm quite happy to use it, right? Who can receive the messages, who can send the messages, because one app is going to send the message, one app is going to retrieve the message. That's what we're saying. One is going to send from here, one is going to receive from here in this side, right? And that's what this is telling you. What permission would you like to want, right? And there is few more concepts, the dead letter queue. So let's create this and then I'll explain dead letter queue and who is going to encrypt with that key ms. If you do that, the same, what key would you like to use to encrypt it, right? And how many times would you like to retry it? And the retry has a consequence on the dead letter queue. So I'm going to explain this dead letter queue as well now. So I created a queue, for example, very simple queue, right? And and now it's saying that who you can subscribe to it as well. Whenever a message come, you can subscribe it. You can have lambda we were going to discuss as an app. So lambda is nothing but it's like a function on the fly. So you can put your code in, it'll run. So you don't need like a spot instance, but lambda is mostly used with websites quite a lot. So I can write a function which will get invoked as the messages come in, like a trigger, right? So we're going to see that with an API gateway and end-to-end, like a web app type. So when you send it through. So but yeah, lambda in just a context that it's a function that you can write. You don't need a full blown machine. You can put your code in there. It'll just on the fly execute. It's just like a runtime function that you call it, right? And and we got dead letter queue. So dead letter queue I'll explain. So what actually happens is that my queue is ready. They've still given this test functionality, like test sort of thing, send and receive messages to see. So let's say that I send a message, right, to the queue, right? And it's saying, okay, just when do you want to delay this message, etc., or do you want to add more attributes to message, add more like a metadata type of it? No, I'm just saying just send this message hello and send it, right? I don't need the attribute though. It's an optional. I would have thought it's an optional one. Yeah, the message, yeah, that's right, because I think I owned it. Then it's so that message has been done, right? Now there's one message available here, saying 30-second is polling sort of duration. That is the default polling duration that you have. So I'll explain that polling as well. Once I poll for this message, it's going to poll for 30 seconds. What does that mean by poll by 30 seconds, right? Let it finish. I'll explain. So it's going to do for 30 seconds. It's going to poll. And there is something called a short polling and long polling. I'll explain both the difference so that so it's going to poll for 30 seconds. It's already got my message. It's already received my message. It's got a hello here in the body. If you added any extra attributes, you'll see it as well, like a metadata type thing, right? And there's two concepts to understand here: dead letter queue and this polling after that, right? Now, what actually happens is that if I put that message, for example, into the queue, my app is going to pick up a message, right? Now, when I go to the queue, I may not have any message in there at all. It could be empty, for example, at a starting point. And I may be just preparing my app can be, going to send the message, right? At some point, your messages will finish, the new one will come, etc., and you can keep on processing it, right? Now, if I just go to the message and check and come back, and there's no message, I still need to pay the cost every time I hit the queue and poll it. There's a cost attached with it. And to reduce the cost, to make it more better, what you do is you go to this queue and you wait for 30 seconds or whatever time you set up, right? And in 30 seconds, if any message comes in 30 seconds, or how many number, whatever it comes in, whatever messages are there in 30 seconds, it's going to pick up all of them in 30 seconds and come back. So it could be 10 messages, it's going to take all 10 from you. And that's called as long polling. And it's more cost efficient because you're going to wait there. You're only going to go once every 30 seconds. If you go in this one, you may have to go every second, 1 second, you may have to poll because you don't know when the messages are coming. If you leave the too long, the messages are going to sit there, right? And it's called as long polling to cut the cost. And you may see in something in exam, I want to cut the cost down. So long polling is the answer. You need to wait there. You need to wait for the app for 30 seconds to come back. And then you have second thing is that, let's say that I was sending maybe a format in XML format or a CSV format, for example, like a CSV, maybe like a spreadsheet. I send the records in. My app, I did a release and that my app had this format saying that first name, comma, last name, for example. When I got a new CSV, right, in which suddenly I've got 3 records. I made it ID, maybe like last name, and maybe like, PIN code. I send these records in. My app is saying first name and last one. This guy is saying ID, last name, and PIN code. I pick up this app, pick up this record. It's tried to work on it, but now you can't understand it, right? It doesn't know what to do with it. It's waiting for first name and last name. We are saying ID, last name, and PIN code. It can try to resolve the problem. If not, what it'll do is it'll push the message to another queue. And that queue is called as dead letter queue. The reason is that you may have more apps sitting behind dead letter queue. That may be just alerting maybe an admin, right? Or it may be some sort of a dashboard to see what the problem is, right? Or you could be logging here, right? Right. So something that if you can't process it, you're going to put it in dead letter queue, right? It could be your database has gone down, right? And you don't know now what to do with the message. If you put it back into the queue, it's going to keep on coming again and again, again and again, right? So one of the ways is that you just go back and put it into a dead letter queue. Once it's gone in dead letter queue, if it's failing, you have other apps and other dashboard to process the message. And this is one of the things you should remember for exam as well, that what to do with the message if I can't process it, right? You need to send it to the dead letter queue, because then I've got an opportunity to see or open that record in the dead letter queue to see, oh, by the way, this has come wrong, right? I could reach out to people. I can still find out what the problem is, right? And and this is quite important concept. So in SQS, always remember few things. Visibility timeout. Yes, you have to remember a visibility timeout for SQS. And then you have the visibility timeout. You have long polling, short polling. I've explained you, and then you have a dead letter queue. These are the three things. And then in the architecture, you'll always have a question to say, what should I do with my app? So you'll always say, let's have some scheduled reserved instances or reserved instances if it is asking for a criticality. If it is not, if it's saying the app is not critical at all, it could be like process my log file. I can wait for a day, right? It's not end of the day. It could not be a critical data. In that case, you always use spot instances because the cost is so less. You're going to pay like 90% off. And if it is not urgent, I don't really care, right? I can throttle it, right? So something to be aware of in the architecture term. And that's what is SQS is all about, right? In simple queue service, that's called. It's showing you can play with it. You can send a message with a tractor, poll for it, and the more longer you poll for it, 30 seconds, the more message is going to pull back and process it. And then you've got first in, first out for any ordering of the message. Make sure when you select and in the examples, when any question come, any ordering of the message, if ordering is there, then it is first in, first out. Same thing will happen. Nothing. It's just that you wrote that the messages will go one at a time. If it is standard, it's very, very fast. But the problem is that you may have duplicates messages as well coming out of it, right? So that's what has happened here. But that's SQS. Any question, guys, on this? I can see Falcone. Sorry, you joined a bit late as well, so hopefully it's not that late, but yeah.
Avanish.
Yeah.
Yeah, this visibility time, you say that is a time for processing the message.
Yes. So what actually happened is that if I let's write this down, then we can see properly. So I'm in the queue. Oh, sorry. I'm in the queue. I send a message one, for example. My message one goes to one of the apps, one of the server, right? Maybe a spot instance. This is going to pick up the message one. I start processing. If my visibility timeout, let's say, is 30 seconds. If my message don't come back in 30 seconds, what AWS will do is basically the queue, wherever it's storing that message, the storage of the messages are, right? What it does is when this message goes there, this message gets hidden. This message, what is picked up, once it's picked up from the queue, the message is still there on the queue basically, but it's hidden, right? And what AWS does is, whatever it does, it restores the messages back. So one will come back into the queue again. All it's saying is visibility means it's not visible to anybody yet. But if 30 seconds, within 30 seconds, this guy who has picked up the message, don't delete it, this message is going to come back again. And that means some other app down the line, whatever server you've got, number 2 or somebody, may get this message again, and you may have a duplicate, right? And it could be a day where, let's say that you're picking up a message and storing in a database, and database is just choking up, right? Or timing out, 30 seconds may go off, right? Or there could be like a network glitch there. You're not able to do anything. So what could happen is you may think, I will do it, I'll do it, 30 seconds goes away. This message one will come back in again. And then it'll reprocess again. And if I think it's 2 or 3 times, if it doesn't get processed, this message goes back to dead letter queue, like we discussed, so that some other app will pick it up. Means you've already run out of chances. As you've tried so many times, there's no point bringing this message again and again back onto the queue. And that's what happens with visibility timeout. Means it's visible, not visible for 30 seconds, and then it'll visible again.
So you mean to say that there's a particular server which picked the message is if it is unable to process on time, that means the time is the visibility time, it will resurface in the queue, right?
Yes, correct. And some other machine may pick it up.
Okay. So actually, you have in the queue the message is already there, but the
It's
server is
hidden.
picking a copy of it. That's
Yeah,
it,
so
right?
means that what they do is you give a copy and then you hide the message. You have not deleted anything.